All right, so we're going to look at some examples of multivariate calculus. The first thing that we're going to look at is just computing domain and range of some functions. So here's our first function, square root of x plus the square root of y. Note that these are separate. This isn't like square root x plus y. So the domain of the function, or the biggest domain of this function, so we're sort of given this rule, and we're asked to identify the biggest domain where this function makes sense. In this case, we need x and y to be positive always. They're separate inequalities. There's no link between x and y. There's no values of x that will make the argument of the y positive, right? So we're assuming this is a real function as well. That's another assumption we should note. So we've got our domain as being this region defined by x greater than 0, y greater than 0, which we can sketch. So the domain of a two-dimensional function is obviously just a plane, or a region within a plane. And in this case, it's the first quadrant of the real plane. So the range of this, what's the values that f can spit out? Obviously, that's just all the positive reals. So there's no restriction other than that this will always yield a positive answer because we're always taking the positive branch of the square root, right? So if x is some positive number, then this part of the function makes sense. Y is a positive number, it makes sense. But we could have 0, so we can get that point there, and obviously we can get all the way out to infinity. So that's our domain and range in this case. Is there anything else I need to say? No. All right, we're done. So yeah, this is our domain, and this is our range, and we're mapping this part of R2 to this part of R, if you want to think of it in a set notation. So that would be the positive reals, and I guess that you would write this in set notation as x, y in R2, the two-dimensional reals, such that x is greater than or equal to 0 and y is greater than or equal to 0. So you're really just stating this condition again.